the universe. So dark, mysterious, and unimaginably vast. Well, what if there was something even bigger? What if our entire universe was inside an unimaginably gigantic black hole? Here's the deal with the universe. It's so humongous that we can't see it all from Earth. So scientists observe what we can see and then make educated theories. A lot of times there's just no way to know for sure. Today, we'll explore how the universe formed and how it might die, how it could have formed inside a black hole, and what would that black hole do to you? Everything we think we know about our universe might be wrong. Now, we do know some things about black holes. First of all, that they come in a variety of sizes. We just haven't found one big enough to hold the entire universe. These light-consuming monstrosities have been around since, well, as long as the universe itself. Yeah, I'm talking about primordial black holes. We haven't seen one, but scientists theorize that in the first few seconds of the universe's existence, pockets of super dense plasma collapsed and created tiny black holes. Well, not all of them were tiny. Some could have been tens of thousands of times more massive than the sun. Maybe one of these swallowed our young universe, and together we kept growing. Okay, we'll get back to the different black hole sizes in a minute. Right now, you're in the middle of the hottest time in the history of the universe, the Big Bang. I'm guessing you're pretty familiar with the Big Bang Theory? Math, science, history, unraveling the mysteries? No, not the TV show, the actual theory. It all happened 13.7 billion years ago. Back then, every atom, material, and molecule in the universe was packed into an infinitely tiny and extremely hot singularity. Then, suddenly, a big bang. Everything expands and comes charging outward at the speed of light. In a fraction of a second, everything needed for complex galaxies to form is spilled out into this infinite space. But here's a problem. If our universe is really inside a black hole, well, then the Big Bang Theory is wrong. Because black holes don't expand things inside of them. Black holes compress. Okay, so scientists agree that the Big Bang is likely how the universe was born, but the universe being inside a black hole doesn't fit with what we know about the Big Bang. So, are we wrong about the universe? Where does this universe inside a black hole idea even come from? Well, I'll tell you, but buckle up, Buttercup, it's science time. Recently, a very curious science paper was published, and it made scientists doubt what we thought we knew about the universe. I'll try to break it down. The researcher looked out at our sky very closely with the James Webb Space Telescope and noticed something strange. About 2/3 of the spiral galaxies in a region of the sky appeared to rotate clockwise, while the other third of the spiral galaxies in that region rotate counterclockwise. Now, what's strange about that? Well, it's unexpected because the Big Bang Theory relies on something called the cosmological principle. It's the idea that on a large scale, the universe looks the same in every direction and in every place. That means that galaxies should be spread out evenly and their spins should be randomly oriented with no overall pattern. Turns out, they're not. And if we start to see more galaxies spinning one way rather than the other across large parts of the sky, that could be a sign that the universe isn't as uniform as we thought. And that would be a serious challenge to the foundation of modern cosmology. Still with me? Good. Well, you know what else is known to rotate? Black holes. Maybe being inside of one messes with the rotations in the universe. Now, here's something that'll really mess with your head. Take all the mass and energy in the observable universe and plug it into the formula for a black hole's event horizon. In that case, you get something pretty close to the actual size of the observable universe. Yeah, in other words, if the universe was inside a black hole, its radius would be about the same as the distance we can see in every direction. Maybe that's just a weird coincidence, but some scientists think it could be a clue. Maybe the reason we can't see beyond the edge of the observable universe isn't just because of light travel limits. Maybe it's because that edge is the event horizon of a black hole. Not one that's sitting out in space, but one that we are inside of. Think about that next time you look up at the stars. More importantly, how does being inside a gigantic black hole affect you? Well, I may have overplayed the way your life would change, other than the fact that you might be living inside an actual bigger-than-the-universe black hole, which is pretty cool. Day to day, your life would be the same. But how would our universe ever have come to exist inside of a black hole? And does that mean our home black hole is inside another universe? And are the black holes in our universe also homes to other universes? Okay, I did the thing where I said universe too many times and now it's lost all meaning. Universe. Anyways, getting back on track. If our universe is inside a black hole, we'd really have to rethink how the universe began in the first place. The Big Bang Theory? Well, it could still describe how our universe started expanding and how galaxies formed, but instead of being the absolute beginning of everything, it might have been just the moment a black hole in some larger parent universe created a new, sealed-off pocket of space-time, our space-time. So, all the stuff the Big Bang model explains still works, it's just plugged into a much bigger story. Now, instead of the Big Bang, it could be the Big Bounce. That's the idea that our universe didn't start as a hot and dense singularity. Instead, it started when the previous universe collapsed. Now, our universe could have expanded and contracted so many times in its history. It could be much, much older than we suspect. The Big Bounce doesn't have to happen inside a black hole, but it could. Now, what type of black hole would that be? Well, in the beginning of this video, I mentioned primordial black holes, but even at their largest possible size, they're not big enough to hold the entire observable universe inside. So let's quickly check out some of the other types of black holes, starting with the stellar mass black holes. As the name suggests, these black holes form when a massive star collapses in on itself. The star has to be at least 8 times more massive than the sun, so don't worry about this happening here. You won't ever see our sun become a black hole, although the view could be pretty sweet. These stellar black holes are everywhere in the universe, but even though they sound massive, they aren't all that large. Stellar black holes are extraordinarily compact. For example, if Earth suddenly collapsed to become a stellar black hole, it would have a radius of about 1 centimeter. It's about the size of your belly button. So, yeah, these black holes definitely wouldn't be large enough to hold our entire universe. But intermediate mass black holes? Let's see. These black holes might sound mediocre, but, well, they actually are. For a black hole, I mean. But they're still impressive, and they have a mass anywhere from 100 to 1 million suns. Still, not big enough to fit the entire universe. But supermassive black holes, now we're talking. These are as massive as at least 1 million suns, and we don't even know how they formed. If we are inside a black hole, it would definitely be a supermassive black hole, right? Wrong. Even though they are unimaginably massive, supermassive black holes are still only astronomically large. They're not cosmologically large. Remember that black holes are unimaginably dense. Even a supermassive black hole that's 10 billion times the mass of our sun would only be about 200 astronomical units across. That's about the same diameter as our solar system, if we include the Oort cloud. No, the black hole that could fit the universe would have to be stupendously large. And I didn't make that up. That's the actual name for these black holes. Stupendously large black holes, or slabs. Well, for now, slabs are hypothetical. We haven't seen one yet. Scientists think that if they do exist, they're extremely rare, or that they exist in unusual environments, like outside of our universe. We might never know. And while we're speculating on what kind of black hole might have swallowed our universe, that black hole could be preparing to end it. Yeah, did you think living inside a black hole would just be a cool fact you could bring up at parties? No. Black holes are dangerous and hungry. If somehow you were to approach a black hole and you got too close, you'd get spaghettified and die a horrible death. Chase, our space correspondent, knows something about dying in a black hole.
Oh God! I don't think they're supposed to stretch like that!
Anyway, we might be inside a black hole, and it might end the universe. Look, there are a lot of theories on how the entire universe might finally end. One popular one is called the Big Crunch. Yeah, it sounds like a delicious sandwich option at an Italian deli or at a KFC. But what it unfortunately means is that the entire universe goes. The idea is that right now, the universe is still expanding from our initial Big Bang singularity, but eventually it'll stop expanding. And when it does, all that mass will have such a strong gravitational pull that everything will begin to contract. The universe will shrink and everything inside it will collapse. Planets will collide, asteroids will have a much higher hit rate, black holes will swallow more and more galaxies. It'll be chaotic. Everything will be destroying everything else until we return to being an insanely hot, dense singularity, similar to the one that started the Big Bang. Or until everything collapses in on itself and forms a monster-sized black hole. So we'd have a black hole inside a black hole, which sounds a bit Inception-y. But these two black holes would just merge into one, even more stupendous black hole. So yeah, it would kill everything you know, but the good news is that the contraction would take as long as the expansion. The universe has been expanding for billions of years, so even if the contraction started today, we'd still have a ton of time. Well, the gravitational forces of the black hole moving inwards might accelerate that a touch. The Big Crunch fits nicely into another theory we've talked about, the Big Bounce. In the Big Bounce theory, the universe doesn't just compress all the way into a singularity. It also expands again in a totally new Big Bang. But this theory doesn't make sense if we really are living inside a black hole. Remember how I said black holes don't expand things inside of them, but rather contract everything. Now imagine throwing a ball against a pit of goo. That ball is not bouncing back. Okay, that wasn't a perfect analogy, but there really isn't anything on Earth comparable to a black hole. And if there were, I wouldn't be making this video and you wouldn't be watching it. We'd both be getting spaghettified. Well, maybe the inward force of a black hole is so strong that it requires some kind of huge cataclysmic explosion for anything to expand. Yeah, there's still some things scientists need to think over for all of this to make sense inside a black hole. So, let's just say the big bounce is canceled and the universe is somehow set to expand forever and ever for all eternity. Well, that's not happening because there's another theory for the end of everything. It's called the Big Freeze. In this model, the universe reaches a point of maximum entropy. That's the state where the universe has expanded so much and distributed all its energy so evenly that nothing interesting is happening anymore. The universe will slowly become so dark and so cold that no life can emerge on any planet in any galaxy. It'll all come to a standstill. The only entities left in the universe will be black holes, but even those eventually decay. If we were inside a black hole, the universe's expansion is a tough one to explain. Like I said, black holes like keeping things densely packed. If the Big Freeze is how it all ends, well, I don't see how that could happen inside a black hole. All these theories are built on different assumptions about observations of the universe. Right now, it's impossible to know which assumptions are true, which makes everything possible, even an extremely violent end. The Big Rip, which, excuse my language, sounds like a fart. Seriously, science needs to revisit its naming conventions. Okay, so the Big Rip is the kind of end where the universe keeps expanding faster and faster, thanks to mysterious dark energy. Now, we don't know what dark energy is, but we do know it's there because galaxies are moving away from each other faster than they should if gravity were the only force at play. It's like there's an invisible pressure pushing everything apart. Eventually, any 2 points in space would be torn apart faster than the speed of light. At this speed, the laws of physics no longer apply, and we enter a rate of expansion that causes complete chaos and destruction. On the off chance humanity is still alive at that point, you'd probably be vaporized in less than a second. You wouldn't even have enough time to register the pain before you ceased to exist. If this elusive dark energy does overcome the forces of a black hole, well, then the Big Rip could still happen inside of it. So, yeah, the most violent option is still viable if we lived inside a black hole. Alright, there's one last doomsday possibility. It's called the Big Slurp. Are you kidding me? Okay, I thought the Big Freeze was going to be the most slushy sounding one, but no, there's also the Big Slurp, more well known scientifically as vacuum decay. Now, our universe is not a true vacuum. It's almost a vacuum, but there are still particles and magnetic fields in all areas of space. If there were to be some kind of high energy event out in space, well, this may cause an area of the universe to go from a false vacuum to a true vacuum, and that would be catastrophic. What starts as a small vacuum bubble would rapidly expand in all directions and at the speed of light and tear up the entire universe. But vacuums existing inside a black hole would be pretty unlikely, given that black holes are constantly taking in matter. So, again, that theory would be pretty irrelevant if our universe were inside a black hole. If we are inside a black hole, well, that black hole could be part of another universe, and that universe has other black holes that could have universes, and in those universes, well, more black holes with more universes. Even if we're not inside one, our universe has black holes that might be home to others. Okay, I did the thing where I said the universe too many times and now it's lost all meaning. tartlets. Tartlets. The point is, the idea is like an infinite cosmic nesting doll. Every time you think you've reached the end, look again, there's another. And in this multiverse system, each of these universes could have their own laws of physics. Like maybe in one universe, large mass has a repelling effect, so gravity works in the opposite direction, and everyone's getting flung out into space all the time. Or maybe pushing something away makes it move toward you. These may sound absurd, but there's just no way of knowing the way different universes have been warped. Somewhere billions of universes away from ours, or maybe in the universe right next to ours, there's an identical version of you doing the exact same thing. There's also an identical version of you living out the dream that you never pursued, Brian. There's a version of you that's married to your crush, there's a version of you that has your dream job, there's a version of you that has my job. You get the picture. There's millions of you out there doing better than you. But don't be sad, because with infinite universes, there are also millions of you doing worse, too. We're getting a little carried away. Well, I'm getting carried away. A small but incredibly fast, unwanted guest is about to swing past Earth at the speed of light. Yeah, this is the tiniest black hole in the universe. But despite its small size, could it still rip our planet apart? In this video, we're sending black holes through Earth, from the tiniest black hole, just 2 centimeters in diameter, to the most massive, stupendously large black hole. For you, on Earth, things are about to get bad. Okay, black holes come in all sizes. Most of them are called stellar mass black holes because, well, they're born when a massive star, at least 8 times heavier than our sun, collapses and becomes a tiny but very dense black hole. This is Gaia BH1, and it's the closest black hole to us, just 1,560 light years away. This black hole is almost 10 times as massive as our sun, but it's small. Its event horizon is only 59 kilometers wide, that's 37 miles. And we'll send it our way in a minute, but for now, let's talk about black holes that nobody has ever observed before. Yeah, some black holes are incredibly tiny, but to see those, we'd have to go back to the very first moments after the Big Bang, when our universe exploded from a singularity 13.8 billion years ago. This is a time when tiny black holes popped up before any galaxies or planets even had time to form. The scientists call these primordial black holes. We've never observed them to confirm their existence, either because these black holes are too tiny for us to detect or because most of them have evaporated by now. But we theorize that these tiny, dense pockets of gravity existed a long, long time ago. What's interesting about these primordial black holes is that they could be as tiny as 1 femtometer in size. But even then, they'd weigh as much as a mountain. Now, for our story, we'll start with a black hole a bit larger, with the exact same mass as Earth. Of course, Earth didn't exist at the same time as one of these black holes might have, but we here at What If, well, we like to imagine hypothetical scenarios, as you may have noticed. And in this hypothetical, a black hole just as massive as Earth is about to hit us. Only you wouldn't see it coming because it would be tiny. So we'll make it larger just for the sake of visuals, but in reality, a black hole of this mass would have an event horizon of just under 2 centimeters, 3/4 of an inch wide. Smaller than a coin, but with the gravity of our entire planet. it would fly by Earth like a bullet, and it would only take 0.04 seconds to do so. Depending on how close to Earth it passed, this tiny visitor could cause devastating effects. With this much gravity, it would pull on different parts of the Earth with different strengths. The side of the Earth facing it would be stretched more strongly than the far side. These tidal forces would put a lot of strain on Earth's crust. Even if it didn't go through Earth, but just near it, this tiny black hole could set off tsunamis, earthquakes, and volcanoes all over the planet. And worse than that, this black hole would yank Earth out of its usual orbit. Yeah, our planet could go on a wild ride a little closer to the sun. And if it did, Earth would face extreme climate change, and fast. Or we could go the other way and move closer to Mars. Now, if Earth left the habitable zone of our sun, things down here would get very cold very fast. But what if this black hole didn't just pass by Earth, but passed through it? Well, it would be like piercing our planet with an extremely fast and massive needle. The black hole would create a narrow tunnel that would go all the way through our planet. Anything in its vicinity would be stretched and torn by tidal forces, or spaghettified. Massive earthquakes would ripple through the entire planet in seconds. Fault lines on the other side of the world would slip. Entire tectonic plates could shift. This wouldn't be a local earthquake. It'd be the crust cracking everywhere at once. Being on Earth for this would be horrifying, and you wouldn't even know why things were going south, because if you remember, you wouldn't see this black hole coming. When it comes to black holes, size doesn't always matter. It's their mass. So let's move on to a more crushing black hole. A stellar mass black hole, as massive as 10 suns. Okay, despite weighing 10 times more than our sun, it would only be about 59 kilometers wide. That's 37 miles. It's less than the distance you drive in under an hour on the highway. But that tiny shadow packs gravity strong enough to shred planets. From the moment this black hole entered the outer region of our solar system, Kuiper Belt, you'd only have about 5.5 hours until total chaos. In 4 hours and 50 minutes, astronomers would see its effects on Jupiter. Now, while the black hole wouldn't strip gas from the giant planet unless it passed extremely close, well, we might detect unusual gravitational anomalies around it. Jupiter would likely experience tidal disruption if the black hole came close, but luckily for this gas giant, no gas would spiral into its accretion disk. That's because the black hole would be moving too fast for that. Another 30 minutes later, Mars would be dangerously close to the black hole's gravitational grip. Now, Mars wouldn't disappear into the black hole unless it was directly in its path. More likely, it would be torn apart by tidal forces or flung out of its orbit. Suddenly, things would start to feel off. Even without light, the black hole's presence would distort the night sky. Stars might appear to swirl around it. This effect is called gravitational lensing, but you'd need a powerful telescope to see it because this black hole is still pretty small in size. At this point, you'd feel like the ground was shifting underneath you. That's not your imagination. It's Earth slightly stretching toward the black hole as its gravity pulls on one side harder than the other. Seconds later, things would get violent. The planet would crack across continents. Tides would surge violently, not from the wind or the moon's pull, but from pure gravity. Earthquakes would erupt everywhere at once. Everything would be shaking, cracking, and ripping apart. During this violent event, Earth might lose the moon if its orbit became too unstable. But our planet would survive. It'd be stretched and damaged, and it would take a long time to recover, but still, it wouldn't become one with the black hole. Not yet. But it could get worse. If this light-speed traveling thing wasn't just a flyby, but actually on a collision course with our planet, you wouldn't stand a chance of surviving. In an instant, the black hole would rip through our planet like a bullet. Only this is a bullet that weighs as much as 10 suns, and it would be moving at 300,000 kilometers per second, 186,000 miles. The moment it hit us, the crust, the mantle, the core, everything would be pulled inward. The black hole would shred Earth with tidal forces stronger than anything you've ever experienced. And then, just 0.04 seconds later, it would tear out the other side, leaving behind a tunnel of superheated, collapsing matter. Shockwaves would ripple around the globe, oceans would boil, and the atmosphere would ignite. Entire continents would crack and collapse. Earth wouldn't be swallowed whole. It would be ruptured, deformed, and left bleeding debris out into space. And the black hole, it wouldn't even slow down. Okay, now, how about another type of black hole? An intermediate mass one. These monstrosities are far more rare, or at least harder to detect. We've found hundreds of stellar black holes, but only a few solid candidates for intermediate mass black holes. These aren't as small as stellar mass black holes formed from dying stars, and not as enormous as the supermassive giants in the centers of galaxies. These types of black holes weigh between a few hundred and a few 100,000 times the mass of our Sun. And scientists think they form when stellar mass black holes collide and merge into a more massive black hole. Now, a black hole 1,000 times more massive than our Sun would be catastrophic. Like any other black hole in this scenario, really. Black holes are bad for you if they come too close, and this one would be devastating. Imagine a black hole 1,000 times more massive than our Sun rampaging through the solar system. This monstrosity would have a more substantial size, too, packing all its mass into a beast about half the size of Earth. As it came close to Earth, just like all the other black holes on our list, it would start tearing the Earth apart with its enormous gravity. On top of the regular mix of volcanoes, earthquakes, and tsunamis, this monstrosity would tug Earth closer, swallowing chunks of it as it passed by. Then, just as suddenly as it appeared, it would pass, leaving Earth with a tilted axis, an unstable orbit, and a civilization collapsing in slow motion. And as always, things would be worse if this intermediate mass black hole were on a direct course through our planet. It wouldn't collide with Earth like a rock. It would just replace the space where Earth used to be, all within a fraction of a second. Earth would start to collapse inward before the black hole even touched our surface. Rocks would lift, and the ground would curve. Time itself starts to come to a standstill near the event horizon. And then comes the breach. The black hole would swallow the planet. Earth would be gone in an instant. Cities wouldn't even have time to burn. They would just stretch and vanish. The black hole would leave a collapsing, molten tunnel through Earth. With the planet's core completely gone, Earth would keep collapsing in on itself, but so fast that you wouldn't even have time to blink. Scary, but that wasn't even the worst of the black holes. Meet Phoenix A star, the baddest, most massive black hole we've ever laid eyes on. This stupendously large black hole has a mass of 100 billion suns. Its event horizon stretches 590 billion kilometers. Just so you can picture the sheer size of this gigantic cosmic death trap, it's 100 times wider than the distance from Pluto to the Sun. Yeah, and it would swallow all planets in our solar system like they were nothing. At first, without warning, strange distortions would appear in the sky. That's gravitational lensing from the most massive black hole in the observable universe. Phoenix A star's titanic gravity would be warping the fabric of space around it. Even before this monstrosity passed through the Kuiper Belt and the outer regions of our solar system, every planet in the neighborhood would feel its galactic presence. Neptune and Uranus would start to drift off their orbits, and a few hours later, the inner planets would get massively disturbed too. Earth's path around the Sun would begin to deform under the overwhelming tug of Phoenix A star. By the time you understood what was happening, the flyby would become imminent. Phoenix A star would be approaching Earth at the speed of light. The oceans facing the black hole bulge upward, drawn by its monstrous gravity. Even though the beast would still be unbelievably far out, our tides would grow beyond anything in recorded history. They would flood everything. As Phoenix A star pulled on our planet, the atmosphere wouldn't be able to hold on. Supersonic winds would tear across every continent, and above you, satellites and debris would light up the sky, dragged from orbit like falling stars. Even the International Space Station would plunge into a death spiral it was never built to survive. At its closest pass, Phoenix A star would tear past Earth at the speed of light. For a few seconds, its gravity would overpower the Sun's. Earth's orbit would shatter and our planet would be flung out into space. Here on Earth, it would feel as if gravity disappeared for a moment. Everything would lift, people, cars, buildings, and then when it was gone, everything would be caught in a sudden freefall. Now, the Earth's crust couldn't handle such an intense gravitational pull. The planet would erupt in earthquakes and volcanoes, rupturing everywhere. And then, after just 0.04 seconds, just as quickly as it came, Phoenix A star would race onward. In a flash, this immense black disk would start disappearing from view, leaving a distorted star field to gradually return to normal. But the havoc would remain. In its blistering flyby, Phoenix A star would permanently alter the solar system, even our sun. Every piece of rock would be launched out of orbit, ejected on the path to interstellar space. Whatever remained of Earth would become a rogue planet, drifting through space, not bound to any star. In this brief catastrophic encounter, the human toll would be incalculable. Our entire civilization would be left to die. Most coastal cities would become underwater ruins. Inland areas would deal with earthquakes, fires, and storms. It would be the end of the world for you. Even if, by some miracle, pockets of humanity survived the 40 milliseconds of chaos, they'd face an existential challenge adapting to a planet that's drifting toward deep freeze in outer space. So, yeah, black holes suck. They destroy everything they touch, and falling into a black hole, even for a nanosecond, would be lethal for you.
Oh god! I don't think they're supposed to stretch like that! This is what Rico thinks is gonna happen to me when I jump into a black hole? Okay. I'm thinking that this is one of them wormhole-y black holes that's, gonna take me to another parallel universe or something instead of rip me to shreds.
I didn't say it would rip you to shreds. I said it would spaghettify you. Spaghettification is the process of being stretched by immense gravity. until you're reduced to a thin stream of matter.
That doesn't sound any better. Besides, I'm more of a Fusili guy. But if that's what it takes for you guys to subscribe to my channel, I'll do it. Subscribe.
You are coming off as desperate.
Yeah, whatever, alright. I'm about to jump into this black hole for just 1 nanosecond. Three, two, one. Can I travel to a parallel universe before I get pulled back out?
You never said anything about pulling you out. That would be impossible.
What?
The black hole's gravity pulls so hard that no amount of force is able to pull you out.
Rico!
You'll be stuck moving toward the center, no matter what.
Oh, come on! Oh! Oh! Oh man, I'm not starting.
Oh, I'm starting to not feel so good.
You're starting to move in slow motion, even if time still feels normal to you. This is because the strong gravitational field near the black hole slows down time relative to an observer far away, a concept known as time dilation.
That's not how Nolan did it in Interstellar.
Yes! I told you that would work, Rico! Never doubt your boy Chase! Oh. Oh. Just like I suspected, the black hole was actually a tunnel through space-time, a wormhole, as the science nerds call it. And the other end has dropped me into a parallel universe, instead of crushing me like Rico said it would. I'm a genius.
Don't celebrate too much yet.
Huh? Oh, for fuck's sake! Even in a parallel universe, everything's out to kill me.
This isn't the universe where you survive at the end of every
Wait,
episode.
what? You mean that exists?
No, that's not what I meant.
Oh, well, of course! Why didn't I think of that? Theoretically, there are countless parallel universes where every possible outcome of every event happens. So all I need to do is keep jumping from universe to universe until I find one where I don't die at the end of every episode.
We're in purely speculative territory now. It can't be that simple.
Watch me, Rico.
Maybe I can find a universe where I don't die, and my YouTube channel is hugely popular.
Oh, hey, that's looking better. Yeah, that's not happening. Let's try again. Hello? Are you guys real? I didn't sign up for this! Huh?
You see that vicious jealousy in chimpanzees. One of the things they attack people over is
Okay. This is getting weird. Alright. Huh. Everything seems pretty normal. Huh. Huh. I'm gonna bust into this hospital and steal all the real. That was a sick way to go. Hey, what's up, broskies? So today, I'm gonna be doing the train prank, where I'm gonna set up 400 mannequins, and we're gonna see which one of us gets hit by the train first. It's gonna be epic.
Holy crap!
Rico!
It's me!
It's me! Oh. Hey, what's up, broskies? So today, I'm gonna be doing... Oh, man. Is that what I look like?
Yes, he is an exact match. Except he has 5% less body fat, 13% more symmetrical facial features.
Yeah, okay, I get it. Thank you very much for being very explicit. What's going on?
After I get bolted into space by this train, we'll see if I survive.
Probably land on the moon, I'll probably land on the moon, or maybe I'll end up in orbit.
I love you!
I love you guys too. Yeah, totally. Oh, let's take a photo. Yeah. No, I'd love to do more selfies. Okay, don't touch me there. Alright, chill. Yo, chase heads, chill. What are those things?
Subscribers.
Huh?
He has 500 million of them.
What? Hey, what up, dudes? That was totally a prank! I'm still chilling. Hey.
Catchphrase!
What am I watching here? It's a prank! I'm just kidding, you idiots! Why are you all screaming?
Bro!
That's different. Bro? Hey, wait! Wait for me! Rico said, you can't jump into a black hole, and I was like, listen up, Rico boy. Chase here can definitely jump into this black hole. So that's what I did. I jumped in and spaghettified, fusillied myself all the way here. And somewhere between all this, I was on Joe Rogan, somebody wanted me to eat a bunch of hot dogs, and now I'm here. So, no matter what sick tech or rad gear you roll in with, you still totally bite it at the end of every episode? That's what you took away from this? I mean, I know it's lame, but no, bro, that's epic. I mean, you might bite it at the end of every episode, but at least you come back, smelling minty fresh as ever. Me? I just never die, no matter how wrecked or busted up I get. But you're living the dream. You've got your face on billboards. You've got mobs of crazy fans who love you. Or want to eat you. I'm not really sure what was happening over there, but it seemed cool. Bro, they're crazy. They keep pushing me for gnarlier and crazier stunts. Now they've got my sponsor, Red Bull. Red Bull gives you wings. Hopped up on this massive live stream. I don't think my body's gonna come out in one piece, bro. Dude. They want you to go into that? Yeah, and I mean, I want to, and my agent's saying that it could slide me into more science-y videos, and that's where the big bucks are, man. But dude, if I go in there, I know I'll be stuck in there forever, just getting stretched for all eternity. I'm no superhero. Not like you, bro. I'm no superhero. Where am I? I've got an idea. I'm gonna get in your pants. What? Bro, I don't think anyone's gonna believe that's me. That suit's way too tight. You can barely move, bro.
That's because he has 5% more body fat than you.
Yes, you had mentioned that already. Thank you, Rico. Wait, did you build this spacecraft? Yeah, bro. Why? Yeah, that's not gonna cut it. Cue the montage. Right now. Start it! Okay, so, if you flew a regular old spaceship into a black hole, it'd be a pretty short live stream. The gravity pulling on the part of the ship closest to the black hole is much stronger than the gravity pulling on the back of the ship. So, it'd be ripped in half long before you reach the center of the black hole. You'd also be bombarded from the intense amounts of radiation escaping from the hole, which would not only disable the spaceship's systems, but also melt your face off. Luckily, the spaceship I've built for you can withstand all that, but the technology required to do so is too complex for puny human brains to understand, so it won't actually be you flying the ship. It'll be me, dressed as you. You just wait here until I go into the black hole. And then you reemerge, with everyone thinking you just pulled off the most amazing feat in the history of the universe! Even though it was me, and I've technically done it a few times now. And then you'll have all the credibility you need to start that science channel you've always wanted. You really think you can fool all my fans, bro? Yeah, bro, I think I got it, dude! I might need a new suit, though. What's up, yars? It's your boy Chase, still alive! Oh, thanks, Slim Jimmy! You're my bro from another mother!
You might want to tone it down a bit. Besides, you still have time to change your mind. I thought this universe was everything you wanted.
Yeah, I think I'd rather have my small group of real supporters than these 500 million monsters. I miss you guys. You're the best, really. Remember when we went to the moon and I made that hamburger that you guys watched me choke to death on? You guys were there with me every step of the way. Plus, you know, I'm starting to think that my dying thing is some kind of superpower. Should I get a suit? Like a super suit?
Wow, that really went to your head.
I don't know what you mean. Here we go, bros! Grab your Red Bulls and crush them on your face in 2, 1! Wah! Whoa, bros! Did it work? Rico, do you see the other chase anywhere? Wait. How did we end up right back where we started?
What are you talking about?
You know, the parallel universes, the other chase, the live stream, the Joe Rogan experience. You don't remember any of this?
No. As soon as you entered the black hole, you were immediately spaghettified to death. And now, you are here.
No, there's no way I imagined all that. Rico, check your hard drives or something. We traveled several very different universes. We jumped in like 5 black holes.
The concept of traveling to a parallel universe through a black hole is extremely unlikely. Even if it was possible, the odds of you passing through the event horizon before dying are very, 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 very low.
But not impossible for someone with superpowers. Oh no, dude! Oh, it's just a prank, bro! Stop being so dead about it.
You are an astronaut tumbling through the greatest stretch of cold darkness in the known universe. It's a place where nothing exists. A place without stars, planets, or galaxies. A place where you wouldn't meet a soul for hundreds of millions of light years. Yeah, this place is called the Boötes Void, or as I like to call it, the Great Nothing. And unless you find your way back to your ship, you'll be drifting through the perplexing dark of this mysterious nothing for billions of years. That is, your frozen, desiccated body would drift through this expanse for billions of years. Because there's no one out here to retrieve you. And what's fascinating about this space is that you've been staring at it this whole time. Yeah, look up into the northern sky and stretch your finger between the Big Dipper and the red giant Arcturus, the 4th brightest star in our night sky. Right there. Now you're staring directly into the void. The Boötes Void. The Boötes Void in the Boötes constellation. You can barely see it from Earth, but it's there. And you don't want to end up there. But that's exactly where you're going. What would it be like to fall into this incomprehensible ocean of darkness? Well, first, it would take you a near incomprehensible ocean of time to reach it. The Boötes Void is 700 million light years away from Earth. And I don't need to tell you, that's far. To put it in perspective, the Andromeda Galaxy is our closest major galaxy, and it is 2.5 million light years away. The Boötes Void is 280 times farther. So even if you could travel at the speed of light, which the last time I checked wasn't possible, it would take you 700 million years to get there. But that's about how long it's taken animal life on Earth to evolve from simple early sponges to fish to reptiles, dinosaurs, all the way through to humanity, to you today. If you tried using our current technology to get there, well, it's beyond impossible. Our fastest spacecraft, the Parker Solar Probe, travels at about 0.05% of the speed of light. At that speed, it would take you over 1 trillion years to travel to the void. Yeah, 1 trillion years. Space is mind-blowing. And even then, you can't ride the Parker Solar Probe because it doesn't have any life support systems or chairs or seatbelts. It's just a probe. But let's just imagine that you could get there, traveling in a ship with capabilities beyond what we currently understand. You know, A what-if hypothetical. Yeah, you jump into your spaceship and leave Earth. But leaving Earth is one thing. Leaving the solar system is an entirely different story. You can't just fly past Mars and beyond Jupiter and the other planets until you get to interstellar space. No, your spaceship would need to be in a specific orbit. That's because in order to leave the solar system, you have to break free of the sun's gravity. Yeah, so you know that Earth and all the other planets in the solar system orbit the sun. Earth speeds through its orbit at about 30 kilometers per second. Your spaceship would have to travel faster than that to escape the gravitational pull of the sun. And you wouldn't just fly in a straight line out of the solar system. You'd have to leave in a spiral. To put it simply, you'd have to make a few orbits around the sun, and each time your orbit would be getting wider and wider. No big deal. You're in a super fast, impossible spaceship. You got this. And as you venture further from our solar system and out of the Milky Way, you'd notice that the sky is growing emptier. Near Earth, our sky is full of hundreds of millions of stars in our Milky Way galaxy. But as soon as you leave our galaxy, those stars disappear. But you wouldn't be in the void yet. The Milky Way spans 100,000 light years across, and Earth sits right here, halfway between the center of the Milky Way and its edge. If you could travel at near light speed and in a straight line to the edge of our galaxy, it'd take you 26,000 years to leave it. Yeah, even in this hypothetical spaceship, it would still take you a very, very long time to get to the Boötes Void. And when you finally leave the Milky Way, like I said before, the stars disappear. Now you would see fuzzy patches of light scattered around. Those are distant galaxies, but soon those would disappear from your view too. Eventually, after millions of years of light-speed space travel, you'd pass the last star clusters like Ursa Major. That's the constellation that has the Big Dipper in it. Beyond that, there would be no more galaxies ahead. The backdrop would become totally black. The crazy thing is that once you get to the edge of the void, you'd still have an astronomical way to go. Crossing the Boötes Void, or even traveling to the center of it, would be another impossibly long haul. That's because the Boötes Void is 330 million light years across. It's the biggest void in the universe. It's huge. Traveling at light speed, it would take you 165 million years to get from the edge to the center. If you try to boil that down to kilometers or miles, it's about 1.5 quadrillion kilometers, or roughly 1 quadrillion miles. That's 1,000 trillion miles, just to get halfway across. That's how big this void is, and that's why they call it the Great Nothing. But let's say you decided to give it a try. Well, entering the void wouldn't be like falling into a pit. There'd be no sudden drop or pull of gravity. It would be just emptiness. There's no matter, hardly any light. By the time you got to the middle of the Boötes Void and you slip out of your ship, you'd be floating in almost complete darkness. With the naked eye, you wouldn't be able to see a single star or galaxy in any direction. The closest galaxy would be over 10 million light years away. And even a relatively bright galaxy at that distance would be too faint for the human eye to see. To you, it would be pitch black darkness everywhere. If you've ever tried cave diving or a sensory deprivation tank, well, you're starting to get the vibe here. Except that instead of floating in cozy Epsom salt water, you'd be floating in an absence of anything. Oh, and did I mention? It's about 3 degrees Kelvin, or minus 270 degrees Celsius. That's minus 454 degrees Fahrenheit. It's as cold as interstellar space can get. Your spacesuit better have good insulation. Now, if you're wondering, how did we even discover something that's essentially pure nothingness? Well, you'd have to go back to the 1970s and early 1980s. That's when astronomers were trying to build a 3D map of the universe. These astronomers were in the midst of measuring how fast different galaxies moved away from Earth when they discovered a monstrous spherical gap in a region of space that could fit millions and billions of Milky Way-sized galaxies. That's odd. Empty space in the middle of space? Over the past few decades, scientists have begun to understand how the universe is structured, and it's probably not what you imagined. To look up into the sky, it might seem that there are trillions of stars everywhere, spread out evenly, but the universe is actually formed out of what are called filaments. These are thread-like structures made of stars and galaxies and galactic superclusters. It's a massive cosmic web, or as some scientists describe it, cosmic foam or quantum foam, where all the matter in the known universe groups together in elongated clumps and leaves bubbles and gaps throughout. The bubbles are the voids. Now, why does the universe have these voids? Well, it's because of that universal force that keeps us rooted to the floor. Gravity. Yeah, you see, since the universe began in a superheated, super-energetic explosion that we call the Big Bang, gravity's been pulling the stars and planets and galaxies into these massive structures. Scientists call them galactic walls and superclusters. And gravity's been pulling them toward each other forever. Well, not forever, but since the time the universe was born 13.8 billion years ago. Over billions of years, these superclusters have gotten denser and have kept pulling more material toward themselves. The dense areas of space kept getting denser, and the empty spaces kept getting emptier. That leaves gaps between these clusters in the cosmic web, or the cosmic foam, which sounds kind of weird. The foam metaphor is kind of tricky to follow if you're thinking about styrofoam. Might be easier to think of it more like sea foam, or like the soap foam that forms when you're doing dishes. When the sink fills up with soapy bubbles and it seems to take up a lot of volume, but you know it's really mostly just a squeeze of dish soap and the rest is air. The universe is kind of like that. It's all intricately interlinked massive galaxy clusters, pulled together with a lot of dead air in between. That dead air is scientifically known as a void, and there are so many voids out there. The scientists estimate that voids make up 80% of the universe. So, yeah, space is vast and vastly empty. If you think about it, it makes sense with all the immense light years of space in between galaxies and stars and planets. Well, you should know, as you've been traveling in space for the past 700 million years at this point. Out of all the voids in the universe, the Boötes void is the biggest one we've ever discovered. So, what would it really be like to fall into the middle of that super void? Well, a void isn't like a planet or a black hole. It's just empty space. If you were dropped into the void from your high-speed spaceship, or somehow tripped and fell into the void, you'd just float in microgravity, the same as you would anywhere in deep space. You wouldn't feel any sense of downward direction because in a void, every direction is down. It would feel like an endless free fall. But unlike in other areas of space, without nearby stars or galaxies, you'd have zero reference points. You wouldn't even be able to tell if you're moving. In the Boötes void, with nothing bright in sight, if your spaceship ran out of batteries and killed the lights, you'd lose any sense of direction and distance that you had left. Because it's the ultimate void in every sense. It's the abyss, the quintessential chasm of nature. Maybe if your spacesuit had hypersensitive, state-of-the-art instruments, you might pick up a few faint glimmers in the far distance, like the galaxies on the edge of the void, or a few of the minor galaxies that do exist in the void. Yeah, because despite its name, the Great Void isn't completely empty. Researchers estimate that there are approximately 60 lonely galaxies floating around in there, and most of them are grouped together in a single filament that stretches through the center of the void. Now, 60 galaxies might sound like a lot, but in a space that big, it's like looking for 60 goldfish in the Pacific Ocean. Your chances of ever bumping into one would be nearly zero. With the naked eye, all you would see is blackness, punctured by nothing. Utter silence, pure vacuum, Vantablack, Xcode 000000. If you've fallen into it or become lost in it without any means of being able to tell where you are and which direction you're moving, you'd be stranded in there forever. Just you and the emptiness of space. Maybe you'd go mad, or maybe if you had a suit that could sustain you, it would be peaceful in a way. There'd be no one else around, nothing to bump into. You'd float there in the darkness, never knowing up from down, forever drifting in the greatest nothing in the universe. So there you have it. Nothing to see here, literally. You know, we probably could have gone with a more visual episode, one that's not completely dark all the time. There are so many better places to travel to. I mean, our solar system is only 2 light years across, and we haven't even fully explored that yet. We have sent probes to Mars and even Venus, but never set foot on those planets ourselves. And not to mention, never been to everyone's all-time favorite dwarf planet, Pluto. But maybe we shouldn't step on Venus, because it's so deadly you wouldn't even last 1 hour on it. A black hole is coming straight for Earth. We could wait for it to gobble us up, but instead, we're going to try to destroy it. We'll throw everything we can at this black hole, from nukes to advanced technology that we might not even have access to yet. Maybe we'll even try to throw a white hole at it. Is it even possible to destroy a black hole? You know what? Enough questions. We have a serious mission to accomplish, and if we don't, humanity will go extinct. This is What If, and here's what would happen if we destroyed a black hole. Okay, our first attempt at destroying this black hole will be to nuke it. We're going to collect every single nuke on Earth and launch them at this black hole that's speeding right toward us. This will produce energy equivalent to 425,000 times the atomic bombs of World War II. Now, we know that the destructive blast of a nuke decimates anything, so all these nukes should do the trick, right? Well, not so fast. Black holes are tricky because what they do is consume. Like some kind of super hungry space giant, they want to suck up all the matter and energy that they can get their grubby little cosmic hands on. But let's try launching our nukes anyway. As they enter the black hole, you sit and wait for the massive explosion that will destroy this celestial phenomenon. But instead of being destroyed, the black hole eats the nukes for a snack. And now it's more massive than before. Ugh, great. Well, as the saying goes, that which doesn't kill a black hole only makes it stronger. Or something like that. Bullets, lasers, and ginormous super weapons won't work either. So, is humanity just expected to suffer the fate of being gobbled up by the black hole? No, you are not going to let the human race die out. But it's clear we have to try a more crafty strategy. One with artificial black holes, white holes, and maybe even a time machine? But Before we get to that, let's figure out the basics. After all, as Sun Tzu said, know thy enemy. So, what makes a black hole tick? Black holes are these super dense areas in space, so dense and so gravitationally strong that not even light can escape them. And it's estimated that our Milky Way galaxy has 100 million of them. Now, a black hole can form in two different ways. One way is when a cloud of gas collapses. These types of black holes can be enormous, 1,000 to 100,000 times the mass of the Sun. And there's a second way. Stellar mass black holes form when a massive star explodes and dies, leaving behind a very dense core, which is the black hole. These are smaller, with masses just a few times that of our Sun. Now, what happens when we get a little bit closer? Well, as you approach the mouth of the black hole, you reach a boundary called the event horizon. And once you cross the event horizon, well, you're past the point of no return. Its pull is just too strong. Like I said, even light can't escape. And if you fell in feet first, you'd actually be stretched and squeezed simultaneously by the extreme gravity and pressure. The official term of what would happen to you is called spaghettification. Sadly, it's got nothing to do with meatballs or a nice bolognese sauce. The scary thing, of course, is that black holes are constantly growing bigger and bigger and bigger by swallowing more and more matter. And now it looks like Earth and all of humanity is on the menu. Oh, and one last thing about black holes. Like many other objects in our universe, they have angular momentum. In other words, they spin and they have a charge associated with them. These are properties that need to sync up appropriately with the mass of the black hole in order to keep it in business. Just like if you were running a marathon, your body temperature and your blood pressure must stay in the right zone so that you can keep running. If you overheat, you might faint and fall over. Keep this in mind, as it might play an essential role in taking down our black hole. Right, now that you've got a handle on what we're dealing with, well, it's time for a new attack. Oh yeah, we know we can't defeat this sucker by simple tricks like nukes. No, we've got to come up with something better. So we're going to do something pretty crazy. Let's try making our own black hole and see if it can defeat the one coming after us. But how do we do this? Well, the first step is making our black hole out of antimatter. Antimatter is just like matter, but with all the opposite properties. It's like the arch nemesis of a black hole. Of course, there's the small problem of actually making a whole lot of antimatter. But no worries, we have the technology to pull this off. All you have to do is accelerate a bunch of protons until they're nearly at the speed of light, and then you fire them into a material like iridium. This collision knocks out some of the fast-moving antiprotons, and the antiprotons are then slowed down and focused to help create antimatter. Oh, and we'd probably need this antiproton gizmo floating in space to create an antimatter black hole at the right coordinates. Definitely a little tricky to pull off. So, what's going to happen when we crash our antimatter black hole into the regular black hole? Well, once these two forces crash, there'd be a mega explosion of pure energy. But unfortunately, it doesn't work as intended. The energy from our antimatter just gets vacuumed up by the regular black hole, and it's now even bigger. Okay, this is not looking good, and the black hole is getting closer and closer and bigger, and we're running out of time. We've got to try something else. Since the black hole is getting bigger from us feeding it, well, maybe we could just starve it. What if we figured out a way to stop it from eating anything else? Well, that wouldn't work either, because the original mass of the black hole would still exist. But what if you tried the opposite? What if, instead of starving the black hole, you fed it with something? Something that's constantly throwing stuff out. But what could that be? My mom? Maybe the answer is a white hole. White holes function in ways opposite to black holes. The two of them are like yin and yang. if nothing can get out of a black hole, well, nothing can get into a white hole. If we threw a white hole at a black hole, the two might just annihilate each other, but they wouldn't disappear. There'd be a big burst of energy and a ton of gamma radiation. You'd want to steer clear of that zone. That radiation will give you cancer. Well, actually, you'd get such a massive dose that you'd probably just die instantly. Besides this, the only problem, well, we don't actually have a white hole, and we don't know how to make one either. Okay, so that strategy's a bust, but we're not gonna let that stop us. We will stop the black hole. This sounds a little crazy, but what if we built a time machine? One that could go back in time and take a black hole out. All we need is a wormhole to connect the black hole with its past. As we go back in time, the black hole has to spit out the mass it's taken in, making it a white hole. And if we traveled back far enough, we could reach the point just before the hole was born and blast it with nukes or lasers or whatever we have on hand. This idea works in theory, but we don't have a time machine or a wormhole. Let's try something a bit more realistic. All right, I got another idea. Maybe we can make a bomb that explodes spectacularly fast. I mean, faster than the speed of light. We need the speed because, remember, even light can't escape a black hole. So we'd need an explosion with escape velocity faster than the speed of light to blast out of there. If we did this, it might blow the black hole apart. The only hitch is we don't have a bomb that explodes that fast yet. So what else could we do? Okay, well, maybe you could deform this black hole. Target a specific part of it. Something like that might kill it. Well, guess what? We've got 4 different deformation options. How about attacking what lies at the heart of a black hole? That is, its density. If we stretched it out and took away its density, well, that would spell the end. But it can only be stretched if it has a finite size, and science isn't sure if black holes do or don't. The problem is, we're not 100% sure about the exact nature of what's inside the black hole. Is it a super dense, stretchable object? Or region where space-time curves, which would not be stretchable? Well, we don't know for sure because nobody's made it past the event horizon. Remember the spaghettification thing? But even without that knowledge, there's a second way you can destroy a black hole, and that's by destroying the event horizon. Without the event horizon, well, frankly, there's nothing for objects to fall into. One way to destroy the event horizon would be to poke a hole in it. If we just puncture the boundary at the event horizon, maybe the mass of the black hole would start to drain out. And with no mass, well, the black hole would no longer exist. But there's a third, more sophisticated way to deform the black hole, and it's got to do with some of the forces keeping the black hole going. Remember I told you that in order for the black hole to exist, the rate at which it spins and the electrical charge of the black hole have to stay within certain parameters? Remember that? Yeah, like when you turn your car around a corner. It needs a certain acceleration to make it around the corner safely. Overdo it and you might get into some trouble. Well, we want to destroy the black hole, so we're going to mess with these parameters. What if we increased the spin and amped up the charge of the black hole so much that its equilibrium broke down? This could be the final answer to destroying our black hole. Or we end up destroying the universe. So let's try something else. Now, could we just slow the spin of the black hole? Sure, we can extract energy from the black hole by dropping things into the event horizon. This will make the black hole rotate more slowly. If we did it enough, we could even make it stop spinning entirely. Now, this might slow it down, but it won't make it completely disappear. Okay, so there is one last option, and it's all about patience. You see, black holes can destroy themselves over very, very long periods of time, and it's because of a weird process that's going on in the background. According to quantum theory, everywhere around us, pairs of particles are popping up, a particle and an antiparticle. When these crash together, they destroy each other. But in the case of our black hole, one particle might go into the hole and the other particle might escape into space. As this happens over time, the black hole becomes a teeny tiny bit smaller, and If we wait a few trillion years, the entire black hole will dissipate this way. You know, they say ignoring your problems doesn't usually solve them, but in this case, it will, after a few trillion years. So, can we destroy a black hole? No, not really. And even if we could, I'm fresh out of new ideas. So if you have any theories of your own, head on over to our Patreon, where you can join a private Discord to chat with us. Maybe you can help us solve the problem. But let's be real, a force this strong is virtually impossible to get rid of. Luckily, the chances of a black hole coming for Earth are just as impossible. Could a black hole devour us all one day? There are millions of them out there, just waiting. And if we happened to make a black hole accidentally, well, you better fasten your seatbelts. Things are really going to suck. Literally. What would we see if we got pulled into a black hole? Could Earth orbit the sun and a black hole? And would we survive spaghettification? This is What If, and here's what would happen if Earth were sucked into a black hole. Just 3,000 light years from Earth is a black hole visible to the naked eye. Thankfully, we're a safe distance from this stellar black hole and many others like it. There are approximately 100 million of them out there in our galaxy that we know of. They are remnants of supernovae, which occur when stars 10 to 20 times larger than our sun collapse in on themselves. Stellar black holes are fairly common and are about 16 kilometers in diameter. And then there's the much larger competition: supermassive black holes. These have a diameter roughly the size of our solar system and a mass greater than 1 million suns combined. One of them, known as Sagittarius A, is right smack dab in the middle of our galaxy. So, how close would a black hole need to be a danger to us? Well, technically, a black hole the size of a 1 millimeter pin could destroy us if it was close enough to Earth due to its incredibly dense mass and extreme gravitational pull. Our survival all depends on whether we've surpassed the event horizon or not. You can think of this as the black hole's point of no return. Anything beyond this point would have to travel faster than light to escape. Yeah, good luck with that. If Earth got close enough, the side nearest to the black hole would begin stretching toward it. Our atmosphere would start to be vacuumed up, and then huge chunks of the Earth would rip apart and follow suit. If Earth managed to fall into the orbit of the black hole, we'd experience tidal heating. The strong, uneven gravitational pull on Earth would continuously deform the planet. This would generate a tremendous amount of internal friction, heating the Earth's core to disastrous levels. It would likely give rise to earthquakes, volcanoes, and deadly tsunamis. The trifecta of doom. Eventually, Earth would begin to stretch in a process known as spaghettification. And not in the tasty, cheesy, tomatoey way.
Mamma mia!
Let's say you were a superhero and decided to fight the black hole head first. Well, your arms would be closer than your feet, causing your body to stretch out vertically and become more and more compressed. Let's hope your superpower is elasticity. For an average-sized stellar black hole, spaghettification could occur several hundred kilometers away from the event horizon. But for a supermassive black hole, physicists believe that this would happen inside the event horizon due to its size. Eventually, no matter what size it is, anything entering a black hole would be ripped into a string of individual atoms. This would happen to anything that crosses it. People, planets, stars, you name it. Unfortunately, our whole solar system would be doomed. The careful balance of the sun and our many planets would collapse, which could send them crashing into one another. And to add insult to injury, our asteroid belt would get sucked toward us. About 200 of the 552,894 asteroids we know of are more than 100 kilometers across. So, if one hits us, we'd be dead before we would turn into spaghetti. Frankly, I'm not sure which fate would be worse. All of the matter in our solar system would join the accretion disk around the black hole. As matter gets sucked into the black hole, it generates massive amounts of radiation, so even if we somehow survived all the asteroids, we'd likely die from the radiation. Believe it or not, astronomers have discovered rare circumbinary planets that orbit two stars. While this may be a possibility with a black hole and our sun, the extreme tidal forces would likely make our planet uninhabitable. And worse yet, we might get kicked out of orbit or swallowed by the sun or the black hole eventually. Sorry, but there's not an outcome where we win here. But, and this is a big but, maybe we could find a way to protect ourselves in some hyper-reinforced space shuttle. If we somehow made it past the event horizon, we might be in for an even stranger time. Physics as we know it would change. Things like gravity, the speed of light, and even how atoms bind and react may be completely different. The truth is, we don't know what would happen. We can't get any information out of a black hole. Would we get pulled into another dimension? End up in a parallel universe? Or maybe we're already inside a black hole. What we do know, however, is that that's a story for another What If. The universe. So dark, mysterious, and unimaginably vast. Well, what if there was something even bigger? What if our entire universe was inside an unimaginable